Okay. It is the unit number 11 we are going to start up today. That is density. What's it? Density. An easy chapter. Very easy chapter. And a very small chapter. Right? We divide this lesson into just two parts. First, we learn about what is density. Okay, what is density? Okay, the concepts related to that. And then we learn about the second part, equation. How to find out density. Okay. But these are the two divisions. I'm going to, merge it to make it easy. At once we are going to do. Right? So, anyone having an idea about what density is? What's this density? Yes. Density is. Those who have already done this lesson at school, what is density? Yeah? Is there a new type of yeah? Unit mass over the unit volume. Unit mass over the unit volume. Misunderstood. Hmm? Fine. Okay. When I take this object, it does have a volume, like it's having a shape. Within that shape, it occupies a volume in the atmosphere. Correct? It is a regular object. Regular objects, you know how to measure the volume. Now, cuboid. Okay. So when you are taking the regular objects, you know how to measure the volume. So it does have a volume too. And for this object, there is a mass as well. Mass is measured in kilograms. Time. But this won't be in kilograms, this will be in grams. It's a small object. Okay. And small object and the density is also less. That is why the mass is less. Okay. Alright. The other way, mass is less, so that the density is less. So how it comes, you'll be learning the relationship, right? So you see, mass is less, anyhow measured in grams. Volume is also there. So what is the mass of a unit volume? Mass of a unit volume, it is what we term as density. So it is something like this. Let me take the object here. The object of mass m, object of mass m. Mass of the object is m. And its volume is v. Right? Volume is v. So we define the density as mass per unit volume. Repeat after me. What is density? Mass per unit volume. Mass of a unit volume. Unit volume means per cubic meter. 1 unit. 1 unit. So how do we find out the density? I got you both the sessions, both the part and merging together. So equation also I'm taking, so it will be easy for you. So the density is equal to mass of the object dividing by the volume. Mass of the object dividing by the volume. How do you find out the density? Mass of the object dividing by the volume. So density is given with symbol D, or as another symbol is also we are given as rho. What is the symbol? Rho we see. Okay, rho. Okay. It is Latin like from the alphabet, we are taking rho, like alpha, beta, gamma, we are taking rho. Right? So rho also can be used here. Right. Anyhow, B equals mass is M divided by volume is. So D equals M over V. This is the formula. What is the formula? D is equal to M over V. D is equal to M over E is the formula. Is the formula. Now, we have to take the units. When we are up to take the units here, the unit has to be in this way. We take the units in two ways. What are the two ways? Standard unit is, now D is equal to M over V. Mass is measured in kilograms divided by volume is measured in, how do you read this? Cubic meters. Cubic meters. Mass is measured in kilograms, volume is measured in cubic meters. This is the standard unit. So the final unit comes kilogram, M3 when you take up becomes M minus 3. How do you read that? Kilograms per cubic meter. How do you read that? Kilograms per cubic meter. Repeat it. Kilograms per. Minus means per cubic. Minus 3 like per cubic. Cubic means 3. Kilograms per cubic meter. That is how we read. And This is the SI unit, standard international unit, right? This is the standard unit we use to measure foam density. Density. And there is another one also. Another one we. Now, I said here, when you come for the duster, it doesn't have a big mass and volume, right? It's small. So the mass is less, volume is less. So I can't be measuring that in kilograms and cubic meters. Okay, what I do, I measure the mass in grams and I measure the volume in cubic centimeters. Grams and cubic centimeters. So you see here, grams, cubic centimeter, it up becomes per cubic centimeter. Per cubic centimeter. So GCM minus. So this is how the units are taken. Units are taken. But remember, this is the standard unit. In calculations, if they ask you to find out the density, you have to convert the grams and cubic centimeter into kilograms and cubic meter. Then you have to find it. If they ask you to find it in grams per cubic centimeter, then you don't want to convert. You understand that? So without asking, even if they are asking you to find out the density, always mass should be in kilograms, volume should be in cubic meter. Did you understand that? Okay. So what is density then? Mass of a unit volume. How much mass is there for a unit volume? In one unit volume, what is the mass? Okay. You take this object. Let me take this as 1 unit volume. This is 1 unit. Within this 1 unit, what is the mass? That is the idea we are taking. Okay. Fine. So shall I write there? What do you do, please? That's right. No clues. What's that? I give the tune. Wait. Last week? Oh. Last week, Saturday also you didn't go. Monday also you didn't go. My goodness. Okay, let's try it there. Density, right? Density is the mass per unit volume of an object. Mass per unit volume of an object. Mass per unit volume of an object. Okay. Or we can say it is the ratio between the mass and volume. Okay. In that way also we can. Now can you see? There is a text box given, right? Guys, inside this text box, you have to write that density. You have to draw this here. Okay. You have to draw this part here. And you have to mark these two. And to the left side, to the right side, you have to write this long. And below that, can you see units of density given? Divided by one line. So these two has to be taken both sides. Clear? Is that clear? Okay, please mark it down. Mass per unit volume of an object. Right, please. Okay. So what is the formula now? Density equal mass over volume. Mass per unit volume is called density. Okay. Now to measure this density, there are some activities given. Can you see the first activity? There's an activity given. I'll give you 2 minutes. Quickly read that form. Quickly read. Read. Okay, right? So what it says? Can you see there? I just got triple beam balance. So what is this balance? This is called triple beam balance. Right? Now, when you come for the substances like this to measure, if it is a smaller substance, we are not going for kitchen scale and all. Anyhow, kitchen scale we are not using here in this chemistry course. Okay? Unless some areas are there. So we use chemical balances. We term triple beam balance, okay, or else 4 beam balance or chemical balance. That is what we are using to measure the mass of the object. Okay. Now, what we do here initially, adjust the triple beam balance to 0. So always, whenever we measure something, the equipment we use must be calibrated at 0. It should be starting at 0 level. Okay. So starting from 0 level, measure the mass of cleaned and dried 500 ml of empty beaker using this balance. You have to take a beaker, 500 ml, 500 milliliter beaker. You have to take. You have to measure it with no any other substances, not a single drop of water. So empty beaker, dry empty beaker total, you have to measure the mass. Okay. So what do? You know the volume, it is 500 ml, you measure the mass of the empty beaker and then you record. The mass of empty beaker we record. Okay. Then what I do? 100 ml of water into the beaker using 100 ml measuring cylinder. Measure the mass of beaker with water. So that means it's something like this. Now, I measure the mass in this way as capital M. Let's say capital M. We don't measure it by numbers, right? I'm just writing in terms. Capital M. Volume of water. I'm going to take 100 cubic centimeters of water. Okay, cubic centimeters given, right? 100 I'm right. I'm taking the volume of water as 100. Okay. Mass of beaker with water. Alright. Now, volume of water is 100. Okay. Volume of water is 100. Mass of water when I take, it is MW, let's say Water is W. Water W. Okay. So I'm taking it as MW. MW. Right? So this MW I'm taking in such a way where I have taken volume of water 100. When I measure this, I get this as 100 MW, let's say. Okay. So actually, water's mass to volume ratio is 1 to 1. 1 to 1. 1 gram contains 1 cubic centimeter volume. Okay. So you see what we do. We measure the volume of water, and that volume of water we measure the mass. But the mass directly pouring water I can't measure it. With the beaker I measure. With the beaker means beaker is M plus 100 MW. Am I correct? What is the beaker's mass? Capital M. To that I'm measuring, I'm adding the mass of water. So this total is what given as the beaker plus water's mass. Only water 100 ml. 100 ml. You understand that? Now what I do? I'm going to take another one. I take around 250 ml. And again the same way I measure. When I measure the mass of the beaker, 250 mW is added. Mass of water is added. Then how much is the mass of water? 250 mW. Then same way I measure 500 ml because up to 500 ml go, it is 500 ml water, right? Water beaker, right? So 500 ml I measure. Mass of beaker is M, 500 mW I measure. So how much is the mass of water only? 500 mW. Okay. Now all these things what I do now, I'm going to take mass over volume ratio. Okay. How much is the mass? 100 mW. Divided by how much is the volume? 100. Okay. 100. Right. And let me add it as V also because volume is V now. Volume is V. So now I'm writing 100 V. Okay. In this case, 250 mW divided by 250 V. Okay. And here 500 mW divided by 500 V. Correct. Now what happens? You can see up and down both same, right? So what I can do? 100, 200, I can come. What is the answer now? MW over V. 250 to 250 also I got. MW over V. 500 to 500 I got. MW over V. Okay, MW over V. So you see, how much mass we take, whatever the mass we take of water, it carries a certain volume, and this mass to volume when you divide, always it gives the same answer. Can you say that? Always it gives the same answer, and this is what the constant value is. And this is called the density. Why? Mass over volume is density. So you see, not only for water, even any other liquid, you measure the same thing. Okay? Always, the values might be different. This is 100 to 100 V2 because only for water that happens. Otherwise, it might be different. It might be different, but for every measurement you take, there will be a mass given. That mass you divide by the relevant volume, always you get one answer. Always you get one answer, and that answer is what we name as density. Is constant. Density is constant for the same liquid, for the same substance. Okay. Density is constant for the same matter. What is the matter into? Water. And if, let's say guys, if you are doing this water with different sources, like one you are taking tap water, the other one you are taking marine water, the other one you are taking brackish water, then it goes different. You are taking the same tap water means tap water. Okay. Okay, now we are going to take the tap water from Colombo and another sample of tap water from somewhere in the eastern part. Different, right? Water content is different, right? Within the same country, even several places are there, water content is different. Okay? The taste, the smell of water is different. Whatever matter with smell, the taste is different, right? Because the contents are different. Contents are different. So that is why same source we have to take. You understand that? Clear? So, and also drinking water is drinking water, distilled water. Okay, but anyhow, there is a constant value for water, and that water we take actually as for drinking, not for drinking water, distilled water. So what is the difference between the drinking water and distilled water? Distilled water contains only H2O molecules. Because water means H2O, you know that. Water means H2O. That is a chemical formula. Water. So distilled water we don't actually drink. That is prepared in laboratories for certain experiments. Okay. So H2O only containing. So only contains H2O means that is distilled water. Then what about drinking water? Drinking water contains H2O plus ions, minerals, salts are there. Other substances are also there. So actually the drinking water, it is a homogeneous mixture. Hope you can remember homogeneous and heterogeneous mixtures. Homogeneous mixtures where the components cannot be separately observed. Components cannot be separately observed. Did you understand that? So accordingly you see density is constant here. So shall we note it down quickly? Take the note please. Same way. Okay. Hope we are done. Okay. Is absolutely. Anyone absent? Boss? Next to you guys, is there anyone absent today? That one fellow is missing. Yeah. That he's missing today. And one more boy was there. Akil. Rehab. Rehab. He's Rehab. No? That okay, okay, okay. The two of them are missing. Right. So what can be controlled by the result of breeding? According to the above factor, it's clear that the ratio of mass to water, means density. It is constant though the volume taken differs. Even though you take different volumes, mass to volume ratio is same for the same substance, for the same matter. So you can see this constant value is specific for water, and this value is known as the density of water. Okay. Now we consider only one matter, right? What if we compare several matters? So that is the next activity. That is the next activity. So what we do here? Here we're gonna take different trees, slightly different. Okay. That is, I'm going to take about the 3 or 4 different materials, different liquids I'm going to take. Okay. Any of the mass of the LCP, I'm going to take it as capital M. Now what I do? Tell me what is the order? First one. First we take water and then concentrated salt solution, kerosene oil. Coconut oil and kerosene oil. Okay. What we do? Look at this. Liquid I'm taking water. And then salt solution. Coconut oil, kerosene oil. Volume of the liquid. Or I'm going to take same measurements, let's say. Okay, it says 250 ml. Can you please read and tell me? What does it say? 250 ml. So, 250 volume. Who is the volume here? Water. 250 salt. 250 salt. 250 volume of coconut. 250 ml volume of kerosene. I'm taking the first slide. To know. Okay. Then what I do? Mass of the beaker with liquid. Mass is capital M, right? When I measure the volume, let's say it is 250 mass of W. Okay, 250 mass of W. And here it is 250, right? Or as I take just without 250, it is MW and MS. Salt solution, coconut oil is MC and MK. Okay. Now you see here what I do. I'm going to take the mass of the beaker with liquid. Mass of the beaker is capital M plus MW. Capital M plus MS. Capital M plus MC. Capital M plus MK. Right? These are just numbers, okay? I mean, without direct numbers, terms. Now what I do, volume to mass to volume. Mass to volume scale I'm going to take. Actually, this has to be, you have to take it, mass to volume. Right? Mass to volume. Now, how do I take the mass to volume ratio here? Now you see, mass is in W, right? Volume is 250 VW. Mass is MS, volume is 250 VS. Mass is MC, volume is 250 VC. MK 250 VK. Now, can we divide it like earlier? Like the previous part, can we divide it in one? And does it give the same value? Is that equal? Not equal, right? So what does it mean? Even you take the same volume, even you take the same volume of different matters, different liquids, different solution, same volume but different. So mass will not be the same. As the mass is not the same, density will not be the same. Density is different. So you can see here, accordingly, density is not the same for different matters. You understand? So different substances in your density is not the same. Density is not the same. Clear the point? Did you got my point? Did you get my point? So accordingly, first one we learn for the same material, density will be same, whatever the mass volume you take. But here you take the same volume, density would be changed because the materials are different. In fact, you take river water, sea water, brackish water. All three water, but three different resources. Three different sources, so they are different in density. Density. So usually salt high means salinity is high, saline water is high. Their density is low. Fresh water density is less. Brackish water will be between them. Brackish water will be in between them. So this is how the density matters. Let's take the note. Okay, so we have some calculations here. How do we find them? How do we do the calculations? Density is equal to mass over volume, right? Mass over volume. How much is the mass? 2000 kilograms. Dividing by how much is the volume? 2 cubic meters. Right? So density is equal to mass over volume, 2000 kilograms, dividing by 2 cubic meters. How much is it? 1000 kilograms per cubic meter. Correct? So, two more questions are there. Give me the answers quickly. Finish. Give me the answers, please. Second one's answer. Second one's answer. Mass of 3.5 cubic meters of seawater is 3000 ounces. I think we have to change this model. You didn't get the answer right? Decimal answer was there, right? I think we have to change it as 3675. Check. 3675. Yes, 3675. Change it. It has to be. So density equals mass over volume. How much is the mass? 3675 grams divided by 3.5 cubic meters. You get 1050. Oh, wait. Yes, give me a minute, please. 3675 divided by how much I gave? 3.5. 3.5. 1050. It is about water, right? Sea water. It has to be 1050. Take it as kilograms. Okay. Because usually, now I could have just given the numbers, you can just divide it to see. But the word sea water is there, right? It has a definite value. It has a definite value 1050. 1050, 1025, 1050 is the usual density of sea water. Water is 1000. I told you salt water is bit more than that. Okay. Right. So you have to just mark it. That's all. So the answer has to be kilograms per cubic meter. 1050. What about the next one? What is the volume? Density equal mass over volume. So volume should be taken here. Density should be sent down, right? Mass over density, correct? You have to subject it properly, okay? Density is equal to mass over volume. So volume should be equal to mass over density. How much is the mass given? 800 kilograms per cubic meter is the density. Kilogram is 200. So 200 over 800. Right? If you have taken 800 over 200, that's wrong. 800 is the density here. 200 is the mass here. So 200 over 800, how much is the answer? Is it 4? 1 over 4. 1 over 4 means 0.25 cubic meters. Kilogram to kilogram, but in minus when you take half becomes 10 plus 10. So 0.25 cubic meter shall be the answer. Fine. Hydrometers. What is this hydrometer? Yes, okay. So hydrometer, when we take hydrometer, is what the equipment we use to measure the density. Hydrometer is the equipment we use to measure density. Density measurements are given by hydrometers. Okay, density measurements are given by hydrometers. And how it is structured? Look at this. Different types of hydrometers are given here, guys. You see, usually in a hydrometer, you have a gravity bulb. It is made up of glass. And this is containing lead shots. Lead means a metal. Lead small metal balls are there, lead shots are there here. Otherwise, when you keep the hydrometer you have to keep it in the liquid. So when you keep the hydrometer in the liquid, if there is no balancing, it will be double down, right? So to balance that vertically, you have some lead shots here. Okay, so that it will be balanced. Otherwise, it floats down. Now, this is a gravity bulb and this is a buoyancy bulb. This is a stem. It is a stem of the hydrometer. And then here you have the scale. Actually, the same one it is there completely. This is a scale. This is a scale. So this is hydrometer. Different types, different shapes, different sized hydrometers are given here. So how do we do that? We are going to keep it partially submerged. We are going to just keep it. Depending on the density of the liquid, for different lengths or for different depths, hydrometer goes down, sinks down. So hydrometer will be sinking down for different lengths. Okay, for different depths, it will be sinking down. So you see here, as an example, right? Liquid A, water, liquid C. Three examples given here. Three examples are given there here. What is the theory you have to remember? It sinks less in high density liquids and more in low density liquids. Underline that or highlight that. It sinks less in high density liquids and it sinks more in low density liquids. You may highlight that. So as an example, you see here, liquid A, liquid water, C is there. It's like this. Now let's say you're gonna take two containers, okay? Two liquids are there in two containers. Two different liquids. Liquid X, liquid Y. Don't write. Now in one, the hydrometer sinks this length. This is the length in X. Okay. And here it sinks length in Y. It sinks more. Does it sink more? Same hydrometer you have to take, okay? Same hydrometer you have to take, or same type of hydrometer you have to take. Right? So you can see it is sinking more in X. Okay, sinking more in X. So what does it mean actually? Now it's something like this. You are trying to push something down, but a person from down pushing it up. Okay. So you are trying to push something down. A person from down is pushing it up. Right? Now, if he pushes more, can you push the object down more? No, right? It will be less. If you are pushing more than the push means a force, right? The force you are giving, if it is more than the person down, then it will be definitely going down, right? Correct? So, likewise. There is a force upward by the liquid given. So, the liquid gives a force called upthrust. What thrust? Upthrust. Two different liquids, upthrust of X, upthrust of Y. Okay. Upthrust of X, upthrust of Y. Upthrust means the upward force. Now here, you can see length in X and length in Y you take. Who is more? X is more, right? Immersing length is more. Submerging length is more in X. Why more in X? Because the upward force is less. Here the immersing length is less. No, why? Upward force is more. It only if person pushing upward, that the force is more than your force, means you can't push it down. further. It's less. Correct? So, upward force in X and upward force in Y you take, whose force is more here? Is it X or Y force more? Y is more, right? So that Y is more, so that length is less. You understand that? Y, in Y, upthrust is more. U means upthrust. U, it is upthrust. Or as we say it as upward force. Upward force. So, L is immersing length. Immersing length. So, you see, U in Y is more. Who has the higher or greater upthrust will be having the greater density. Density. Upthrust more means density is more. So that is why we told you earlier, it sinks less in more denser liquid. It sinks more. It sinks more in less denser liquids. Less denser liquids. You understand that? So accordingly, it is sinking more in X. So X should be less denser. It is sinking less, small amount, less in Y. Y should be more denser. Y should be more denser. You understand that point? Is that point clear? Okay. So accordingly, shall we mark this down quickly? You can go to this part, the last page notes. Right there. Comparing densities. Take logic comparing densities. Comparing densities. And then draw this quickly. And these are the key points they are using. Quickly mark it down. Okay. One example is there here. Let me see now. In this, the liquid level, you see here, this is the length in A. Okay. And this is the length in water. And here the length in C. Now when we compare, we are writing here. Okay. When we compare length in A, length in water, length in C, the immersive length. Who is more? C is more, right? Can you see? C is more than the water and then A is the lowest. Now tell me, who should be greater in the density then? A, W, C. Immersive length more means density should be less. Correct? Tell me what happens here. Immersive length more means density should be less. Immersive length less means density should be more. So when I compare the densities of A, densities of W, density of C, it has to go in this order. Correct? You understand that? So A is more denser than W, C is less denser than W. Clear the point? Okay, mark it down. Right. So this is how to measure. When you cover the liquid, okay, correct reading, incorrect reading, two rings are given. Usually a liquid in a container will be having such a layer. Let's say, now this is a liquid layer. And here you got the hydrometer. Hydrometer has measurements like this. Okay. Now, can you say this gives one measurement and this gives another measurement, correct? Which measurement we are supposed to take? This layer we term as downward meniscus. What meniscus? Downward meniscus. And this layer is called upward meniscus. What meniscus? Upward meniscus. Right? So the downward meniscus is this is the upward meniscus, downward meniscus. So for all the liquids, we measure from where? This is incorrect reading. What is the correct reading? Here. Can you see? What is the correct reading there? We have to get the measurement at this point. This is the correct reading. So this is the correct reading. Correct reading. And here it is incorrect. It is not correct. You understand that? So correct reading we have to take on the downward meniscus. The layer, the downward layer where it touches, there we have to take. But remember, this is for any liquids except one. Who is that one? Mercury. Mercury. So this has to be taken only for mercury. Mercury or mercury we say. Only for mercury you have to take the upward meniscus. Okay. So correct reading is taken at downward meniscus we say. Okay. Correct reading at downward meniscus only for mercury at upward meniscus. Only for mercury at upward meniscus. You understand that point? So all other liquids downward meniscus. Okay. All the liquids downward meniscus. Only for mercury upward meniscus. So can you mark it down in the same diagram? Take a different arrowhead and mark it. So here itself you can write correct reading code is already given, right? Correct reading code is given. Bottom of the meniscus given, below that right, and downward meniscus. Okay. And here, in between these two words, there is a small space. They are taken an arrowhead separately and mark it there. Okay. You have to start the arrowhead from here, from the upward meniscus. Mark it as at upward meniscus only for mercury. Right. What is this fellow doing? Huh? Swimming. What is it doing? Flying. Why is it not going down? Nodding down? Because someone is pushing up or holding up, you know? Huh? What is the sea? Dead Sea. Dead Sea. Why? Are we being dead over there? Then? Because of salt. Can I remember I told you earlier? If the density is high, it will be pushing up. This is a place with greater density. Because more than the maximum salt is dissolved. In fact, maximum it is saturated with salt. Extra salt is deposited everywhere. In the same coastal areas also you can find this salt. Okay. So because of that, a big upward force is there. Due to the upward force, how much you try to draw down, you won't go down. You will come back again. Okay. So you will definitely come back again because the upward force is very much high. So people from okay, people used to visit over there. People used to visit over there. But you know, there are different sort of happenings actually behind this scene related to the history and all. Okay, religion wise as well. But anyhow, here these people they keep floating on because of the upward force. Upward force. Now, then is it a very suitable place to kill someone? No, you are going to draw. You are going to pull or push someone down. Can you kill? No, you can't. Why? No, I'm not saying to kill someone. Just you see, again, you can't do that. Why? Because you how much you try to pull him or push him down, they won't go down. He'll come back again. He'll come back again. Okay, fine. So, furthermore, some examples you can see. These are some liquids having different densities. So, densities are given here. What are you supposed to understand? Who has the greater density? They are the immersing length will be more or less heavy. Greater density means immersing length is more or less. Immersing length is less. Greater density, liquid floating. More mercury. No. Okay, more mercury the same. Actually, yes or no, that's a different story. Mercury, let's say like a sea we are making of. Mercury sea. You go over there, you know what happened? Mercury can go inside your body, which is a heavy metal. Okay, it is something like a suicide attempt. Understand? Something like a suicide attempt. That is why you know mostly now mercury containing stuff you don't use, right? Some of the stuff you are there, and some of them because of wrong disposal methods and all it has been banned, like mercury mercury. You call this thermometers and today we are using alcohol thermometers or digital thermometers we are using it. But because when you dispose them, even a small mercury part, you know, it's being broken and small mercury parts are going inside our body, it becomes a problem. It is affecting our nervous system, kidneys basically, because it's a heavy metal. Okay, heavy metal. So we can't be working with. And not only that, even with some other metals also mercury can go down. For example, you take gold. Gold you mix up with mercury. Mercury goes inside gold. Within that, yeah, you can't take it out. It damages. Okay, fine. Anyhow, we say accordingly, different densities are there. What we have to understand here is higher the density, lower the immersing length. Lower density, more immersing, more the immersing length is. Is that clear? Okay, so accordingly, the last part, look at this. You are going to take a small hydrometer, okay, immersed in water, and while it is in water, now you have finished marking. Right. Also the same same thing, different ways it is given. Okay. I have already taught you, but still the activities are there. Something like this. You're going to take a water container. Okay. You are taking a stroke. One side you have sand. It's sand. Otherwise, it won't be vertically. Then now you may think how can we keep the sand if it is a stroke? One side you are going to heat it slightly and it will be melting, and then you are fixing it like the tubes also we do, and then you are going to apply some sand vertically position. Then we measure how much length goes down. How much length it goes down. So let's say this is the length in water, and again what you do, you are going to put. Now you mark this level. You mark this level. Okay, you are marking because it is just a stone. You don't have any scales, right? You mark the level. Then what you do? Same amount of salt water you take. Now this is water, salt water you take. Tell me, this level will it be above or below? Think. Why above? Because density is more. Yeah, density is more. Now it's clear, right? Density is more. Above the line would be somewhere here. So this is the length in salt it immerses down. You understand that? So you see the length, the line is above. This is the marking length. So you can see marked level. You can see there. Okay. So it shows you length in water, length in S. What is more? Because the density is more in O. Salt solution. Clear the point? Quickly mark it down. Hurry up. Take a mark. We are taking from 2 more minutes. So it's easy. The last part we are in. Anyone's having the exams close by? Amazing. Busy. Finish. How's it going? So you have to make sure you are writing answers for the exercise, okay? For this lesson. 10 and 11 both, okay? 10 and 11 both you have to do. And the latter part speaks about uses of hydrometers. Different types of hydrometers are there. Lactometers we are using to measure the density of, to compare the density, the purity of milk. The cow milk and all we take to measure if it is, high. Otherwise, if it is added with more water, density goes down. So the immersing milk will be moved. Okay. So thickness higher means in any liquid, if the thickness is high, density is higher means immersing length will be less. Adding more water causes the immersing length more because density reduces. Density reduces. So to measure and compare the purity of milk, we are using lactometers. Alcohol meters to measure and compare the purity of alcohol beverages, alcohol strengths. Okay, alcohol meters. So you have to read them. Soil hydrometers we are using to compare the densities of soil samples from different places on earth. We are taking soil samples, mixing with water for certain amount. We measure how much density they have. So different types of hydrometers. Okay, not the same like hydrometers. Different types of hydrometers are there. soil hydrometers where they have been used. Seawater hydrometer we are using to measure different seas. Like the sea, Dead Sea, Arabian Sea, Caribbean Sea, different seas are there. Okay. So to measure and compare their densities, we are using seawater hydrometer. And then metrolab we use to measure compare the densities of metrolab, combustion of rubber. How much rubber it contains? How much rubber it contains in a certain material to measure we are using metrolab. And lead acid batteries also that we use. Okay, lead acid hydrometers. Okay, so to measure what is their density, to compare the densities. So accordingly, different density meters are there. All of them are used to measure and compare the densities of that particular material. So accordingly, that is the end of the lesson. So the 11th chapter is also totally done. Make sure 10 and 11 completely you do the exercises. Okay, please refer all what you have done. At the next class, you have to refer the lessons and probably you would have some questions to be done. Sure. Okay, fine. So, till then, good morning. Salam.